Imagine getting your pee in your shoe. Walks. You just like fold it.
I don't want to hold you.
I don't think you can do what you rather do.
You still don't have to hold it.
So,
You still don't have to fold it if you have a thumb. I don't want you to have to fold your fingers in your shoe.
So we're gonna go over this. The first one you needed to solve, distribute one side, and then remember that when you have variables on both sides, you get to choose which one you want to move first. How did someone start this? Okay.
Where is my brain today?
I felt that really hard. So subtract 11. If that's not how you solve that, that's fine. Don't erase. And since we moved our 11 to the left, we have to move our number to the right. And then divide. So x equals -6 was your answer for that one. For number 2, you may have had to dig way back in the back of your memory to remember what a relation function is. But if you have the same x going to different y's, so like in this case, we have this -1 going to 3 and this -1 going to 2, this would not be a function.
Can you explain that one more time?
So if you have the same x going to different y values, it's not a function.
Oh, okay.
You can have y's going to, or let me rephrase that. You can have multiple y's with different x's, but you cannot have the same x going to different y's. It's like, I was going to say relationships, but some relationships are not monogamous, so that would, anyway. For number 3, translate this equation 3 times the difference of, since I'm multiplying 3 times everything else, this part needs to be, next part needs to be in parentheses. So the difference of a number, pick whatever variable you want, and subtract 7. Is going to be my equals 18. You didn't need to solve this one, just translate it. Questions on those 3? Number 4 was a little challenging because we needed to first set this up and then solve this. And we haven't really talked about word problems yet in here, but any of you may have in previous classes. So for this one, the Buffalo Bills scored 24, more than twice the number of points that the Miami Dolphins scored. Altogether, they scored 66 points, and we're looking for how many did each score. So those are important pieces of information. So I would take each part and kind of break it down. So we know that the Buffalo Bills scored 24, more than twice the number of points Miami Dolphins scored. I don't know how many points either of them scored, so we need some sort of variable. I'll say B and M. You could use B and B, whatever. To be the number of points they both scored. So always define a variable, and we'll get into this more when we actually talk about word problems. But define a variable if there's something you don't know. For our Buffalo Bills, they tell us that they scored 24, more than twice the number of points Miami Dolphins scored. So I could set that as an equation. B equals 24 more than, or I'm adding, 2 times however much they scored, Miami Dolphins. I don't know what that is. But I know that first sentence tells me that much. It says altogether they scored 66 points. So if I knew what B was and I knew what M was, I could add those together and get 66. I don't right now. But I do know that B equals this. So I'm going to take this and put this in for B. Now this is an equation that I can start to solve. So I can combine my like terms and solve for M. What is that, 14? That sounds right. Yeah. And then once we find one, we can put that back into the other and find the other. So I can take 14, put it back in for this equation we found for B, and figure out what that is. 52. So again, that one was a little harder. But our final answers were Miami Dolphins scored 14 points, Buffalo Bills scored 52 points. Any questions on how we solved that one? I'm going to start number 5. I don't know if we'll have enough time before lunch to finish it, but then we'll finish it when we come back. If we have 2 fractions that equal each other, how would we start solving them? Cross multiply. Once they're out of that fraction form, then it looks better, it's easier to solve. So you can distribute, pick something you want to move. Let's say I chose 2. Then I could get x by its square. I actually did do that. When we get back from lunch, we're going to go over a couple more examples in our linear regression notes. I'll give you time to practice. And then we're going to start our last section of notes after that practice. But just in case you didn't, so whatever I originally had planned on the course calendar, those dates have not changed. So today we're going to finish these notes and start our last set of notes. Tuesday, we're going to finish those last notes. Thursday, we're going to take the quiz on this. Remember, all of that goes in the second marking period. No more grades go in this one except for when you retake. The following Monday, so that's the Monday after homecoming, those of you that need to retake, that's when you're going to take your benchmark. I will send out announcements, reminders for that. And then that Wednesday, the 27th, is when we're going to go over the quiz and then take the tests on this unit. So I will put those dates. I did change the quiz and test dates in Canvas already. So you can check those if that's how you get dates. If you want to change the dates on your course calendar, you can do that. But just keep those dates in mind. I also put those dates on the board when your quiz is, when your test is, when the benchmark is. That way you know those dates. So just keep those in mind, and I'll send out announcements and reminders as well. Okay. For this next example, this is really for when you're at home practicing, you don't have access to a graphic calculator. This is what this is for. I would say, yes, this is fine to practice with at home, but you won't be using Desmos on the quiz, on the test. So while you're here, practice with a graphing calculator. But right now, for this example, you can use Desmos. I have something starting right there. I'm sorry. That was better. So after this example, if you don't have your calculator, you can grab it. Not right now. But you can do this one along with me on Desmos. So if you have the app, you can go to that, or you can just go to desmos.com, the website, but go to the graphing Desmos calculator. When you get to Desmos, if you're on this page, you're going to hit graphing calculator. And then on Desmos, it's actually a little easier than on the calculator. You hit this plus, and it gives you different options. You want the table option, so you can insert data. On your notes, the table is kind of blurry, so I'm going to put it up here. You can look off mine or the table. But you would fill in your X's and your Y's.
Sorry about that.
You're fine. Once you have all of those in your Desmos table, underneath your table, you're going to add in, it's going to kind of look like your equation for a line. It's going to represent the y equals mx plus b, but it's going to look a little different. Instead of y equals the m and the x, we're going to use x1 and y1. So it would be y1, and I just typed y and then hit 1, and it made it a subset. And then instead of equals, if you go into the ABC, you're going to use this symbol, the squiggly line, it's called a tilde. And then m and x1, and then plus b. So y1, the tilde, the squiggly line, m, x1 plus b. And when you put that in, it gives you your slope and your y-intercept. On a normal graph, when you start putting the data in, you won't see anything. But if you go back to your table, there should be this little plus at the bottom. If you press that, it will zoom in to where your data is. last class, I don't believe I showed you what this one looked like. But remember, this is called a line of best fit. It doesn't fit all of the points, but it fits it to the best of its ability. It's close to all of these data points. And then to write your equation just in the next line, you can take your slope and take your y-intercept and put that in here. So y equals, I would use all of your decimals since there's no way to like store it really. And actually, I feel like I did something wrong because that's not what it should be. Let's see, one of these numbers is not the right one. I think this is supposed to be a 3. That looks more like what it's supposed to be. So yeah, this one was a 320. I put 520. That was my bad. Okay, so in this one, I can put y equals 13.073. Here we go. X plus 168.212. The line it graphs is going to overlap the line that was already there, and that's okay. This would just be the equation that you would write down. Any questions on how you would use Desmos to find your line of best fit? You okay?
No problem.
We're going to do another example together, then I'll let you practice some. Go grab your calculator. So anytime you have an example where you're given years, you're going to do this a little different. Because before you start putting this information into your calculator, if this starts off with years, you're going to change the first year to be 0. And then every year after that is how many years has it been since the first year. So 1925, it will have been 5 years since the first one, so this would change to 5. 1930, it's been 10 years since the beginning, and keep going. So change all of your years. You should end up with 0 to 80, counting by 5s. Oh, after you change those years, then we're going to put this into our calculator. Reset your calculator, just because a lot of people have used this. Second plus 7, 1, 2. We reset it. 13 plus 7, 1, 2. And then after you reset it, you're going to go into your stat button. Go into edit, by pressing enter, and start putting in all of those numbers. Put the years in L1, the male life expectancy in years in L2. And I'll give you a second to do that. See a few more people putting in numbers. I'll give you a little bit Once you have all of your data in here, following your step 2 on the pink sheet or in your notes, you're going to go back to stat, scroll over to calculate, go down to your number 4 or just press 4. Make sure this says X list L1, Y list L2. Scroll down to store regression equation. Hit alpha trace. Wherever you want to store this, select it. I always put it in the first one, so I hit enter. And then enter again and again. And you should get something that looks like this. At the bottom of the notes, it asks for life expectancy, and then right next to it, it says questions for 3 lineup best fit. That's where we're going to put this, but we're going to round to 2 decimal places. So y equals 0.23x plus 56.06. So that would be the equation that best fits this line of data. It may not go through all the points, if any, but it's closest to the set of data, whatever. And then to answer the other part, the life expectancy in 2010, we have to know what number this would be. So if 2000 was 80, 2010 would be 90. And we're going to make our calculators do that work because we want all the decimals in our calculator along with the 90. So on your calculator, go back to your home screen, that's second mode. We're going to store 90 for x. So I'm going to put in 90. Go to my STO above my on button. And then press my X button, which is right next to alpha. And then hit enter. 90 is now stored for x. Now I'm going to go back and I'm going to grab the equation I stored in Y1, alpha trace. If you didn't store it in Y1 and stored it somewhere else, just grab whichever one that was. And hit enter, and enter again. That put 90 in for x with all of the decimals and solved it. So we can say life expectancy in 2010 is 77.03. So all of this is really calculator work. You're doing all, or if not all, almost all of this in the calculator. The calculator is doing everything. Somewhere where you have space, I want you to write this down. So this is interpolation, extrapolation. So wherever you have space, I know that's not a lot of places, but find some space that you have and write that somewhere on your notes. So interpolation within the data points is if you're looking for something like after you found the line of best fit and it asks you to find some number, If that number is within the set of data points that you were given, you are interpolating. If that number is outside of the set of data points you were given, you are extrapolating. So to see a couple of examples of that, sorry, does anyone still need this? Okay.
If the data points range from 1 to 40, would your age be an interpolation or an extrapolation?
Say that again?
The age range from 1 to 40, your age, would that be an interpolation or an extrapolation?
Interpolation?
Why?
Because I'm 15 and it's 140.
Never. What then?
But yeah. So the examples we did, you still need that, sorry.
Yeah, sorry, my
It's okay. The very first example we did when it asked about predicting grades, the 0 example, when we had to find if a student studied for 0 hours, what would their grade be? In a second, I'll go back to the first page where we were given random data. Let me know when you're finished.
I'm done now.
Okay. So in the set of data we were given, we're looking at our x values. 0 was outside of these x values because our lowest is 1.5. So that would be an example of an extrapolation. So I would go in and write that just like next to it, just to remind me that we extrapolated here. I know I'm flipping back and forth a lot, I'm sorry. Yeah. And then for the 6 hours, I have to look back at my data to see if 6 fell within our data, which I for sure did. So I see our highest is 7. So 6 would fall within that set of data, so we interpolated them. You can also kind of do that with your, like if you're given y values and have to find x values. Because that question asks above 100. Above 100 is not in this, so that would still be extrapolation. So if you see the number, or if the number would fall within the set of data points, you interpolated it. If it wouldn't, you extrapolated. So like the example we just did with years, would 2010 be inside this data or outside? Outside. If I said something like 1994, that would be something inside this data we would interpolate. So as you go through and you practice some of these, I would write next to it if you interpolated or extrapolated. So until about 12, I'm going to give you guys time to go through, practice these, use your pink sheet or your notes for the steps, go through the different examples. I don't really care which page you start on, but if you have multiple examples of pages, you can go there and practice. And then at 12, we're going to start the other set of notes, but then not finish them today. Some of you practice different ones. Next class, after we finish these notes, you'll have more time to go back and practice this. But I just want to start this. We'll probably do like 1, maybe 2 examples, and then we'll be done. In the notes I just gave you, flip to the last page that looks like this. There are a bunch of different examples in this, but a lot of them I mean, it's good practice, sure, but I want you to see more questions that would be like the quiz and test, and that's more like these. So with these, I would recommend that as you read it, highlight, circle, underline anything you find important. That could be numbers, any variables they give you, the question, what is it asking you to find, anything like that. So for number 1, you're visiting Baltimore, Maryland, and a taxi company charges a flat fee of $3 for using the taxi and 75 cents per mile. In that, what's important? Or what do you think is important? Okay. Flat fee of $3. Anything else you find important? Sam? 75 cents per mile. Everything else there is really fluff. You don't need that. Flat fee, just in case you weren't aware, you're going to get charged that no matter what. So even if you don't go a mile, they're still going to charge you that $3. Anytime you see the words per for each, you're going to multiply. Sometimes these will give you a variable to use. Sometimes you'll have to make up one. So for part A, you have to write an equation to find the cost of the taxi ride. It tells us that X is, or that X represents the number of miles, and Y represents the total cost. So we don't have to define a variable, it told us that information. Total costs means we're adding these two together. Adding the two things they told us, the flat fee and the price per mile. Total is also what it would end up with, so we can say Y equals. How could I put 3 75 cents per mile and X together in an equation? Or how could I put any of this together? 0.75 per mile. What could I do with this and X? Or what could I do with 0.75 and 3? What operations are we using? I know I have them written up there, but are we going to add, subtract, multiply, divide? What do you guys think?
Can you guys take Uber? Taxi, same thing. Uber?
Oh, I did Google.
Yes?
Yeah, I did Google.
Internet Uber?
Yeah, I'm thinking of
They're going to see it too. Well, no, actually, does Uber do that by the mile? They charge ahead of time. They tell you that this was your cost.
I think it's a distance thing that's ahead of time. So are we adding, subtracting, multiplying, dividing? Multiplying what? And that number is going to be our X. Yeah. So we have 0.75 and X. What do I do with that 3? So total told us to add them together. Per told us to multiply. It told us our variables and our numbers. We just had to put all that information together.
If you go to 7-Eleven down there, not the one next to our school, but the one that's 3 miles down the road, we got what would you got at 7-Eleven? A big dog.
I like to get, this place was something I always get some.
You go to 7-Eleven 3 miles away, how much is it gonna cost you to get there? With your tax.
And I would like to get the hot dog, one of the little, like, tortillas, how it's called, little stick thingies, and then a drink. Specifically got the pepper.
Is it gonna cost you more than the hot dog to get down there?
Yeah, maybe. I mean, gas. I might speed, not just pay a ticket.
We're gonna pretend you didn't say
I mean, I really want that hot dog.
that. Okay. For part B, it asks how much would the taxi ride for 8 miles cost? So that variable we didn't know, we now know is 8. So we could put 8 in for X and figure out what Y is.
That's probably a better 7-Eleven.
Oh, you're talking about the one over down. Got it. I was like, where's the closest 7-Eleven? But I know it now. Someone put that in your calculator. What would that be?
Okay.
Probably. 3 and 3 plus 3. So for this particular taxi company, if you rode for 8 miles, it would cost you $9. Almost like $1 a mile.
I don't have any money to buy your hot dog.
For that last part, it now gives us the cost, and we have to find the number of miles. So we can put 15 in for y, put the rest of our equation, and we have to solve. And how would we solve this? Off the top of my head, I don't know what 12 divided by 0.75 is. 4, 7. I was getting there. Oh no, you're good. You said 6. 16. Okay. With the most important thing with this is make sure your equation is set up right. That way you get the correct answers for everything else. If your equation is not set up right, then you won't have the right answers. And make sure you have your units for whatever. So part B, it was asking about costs, so your units would be dollars. Part C was asking about number of miles, so your units would be miles. Okay. So next class we'll come back and we'll do more of these examples. And you'll have time to practice more of the linear regression.